Integrator Series Basic Training Chapter 7, General Purpose I/O and Control Numbers. After completing this chapter, you should be able to describe how software and external control devices connect to the Symetrix 761 and Jupiter DSPs connect to enable manipulation of signal parameters. Explain what a control number is and where to find static control numbers for the Integrator series of DSPs. Discuss the operating range of parameter values and how they apply to different controls, for example, faders or mute buttons. Access and use the external control wizard to connect and configure controls, i.e. switches and potentiometers. Understand the use of local logic outputs to drive LEDs or control an external relay for switching other equipment such as a projector screen. This chapter covers Symetrix 761 and Jupiter DSP hardware connections for third-party devices and external control, including instructions on how to locate controller IDs for the various parameters. The features and techniques described in these chapters can deliver an incredibly integrated and user-friendly experience when implementing a system using one of these DSPs. However, in many cases, this type of complexity is not necessary to deliver an exceptional AV solution. Symetrix 761 and Jupiter DSPs are equipped with an Ethernet port. These ports may be used for both software control and remote control. Generally, no special configuration is required for the Ethernet port for control. The default settings, quiet mode on, echo off, are typical for most applications. Quiet mode on restricts the output to just ACK, acknowledged, NAC, not acknowledged, or simple values. Echo mode off prevents all characters that are received over the control port from echoing back. The following slides discuss options for advanced configuration of installed audio systems using DSPs in the Integrator series. To understand what is happening under the roof, we're going to take a look at how you might want to create a bespoke system file using either the Symetrix 761 or Jupiter platforms. Much of the time, this level of configuration will not be necessary. However, it is useful to understand how the control software interacts with external controls. This can help the designer optimize a system for an Integrator series DSP. This is also useful information to have when considering an open architecture DSP solution like the Symetrix Radius or Prism models. First, let's cover a couple of terms we'll use that honestly gets a bit confusing. Parameters are characteristics of an audio signal that the system is or will be processing. These are the usual qualities and states of a signal that audio engineers are using to work with, such as muted, unmuted, gain level, EQ settings, etc. When using DSPs in the Integrator series, the platform defines the available range of values for any parameter numerically from 0 to 65535. More on this in a second. We'll refer to controllers as the software's graphical faders, buttons, and fields that are used to design a system as well as use physical external control devices that connect to the DSP either through the ARC port or via general purpose I/O. These are typically installed for end users and may include volume controls, mute buttons, or other devices such as fire alarm systems. In the Integrator series DSPs, each software controller is assigned a static address at the factory. These controller numbers are numeric and in the Integrator series will not change regardless of your configuration choices. In a few slides, we'll look at where you can find the controller numbers for any Symetrix 761 or Jupiter software controller. External control devices will also have a control number that is defined using two mechanical selectors within the physical device itself, and we'll look at those as well. For example, a fader's location in the GUI corresponds to a parameter value behind the scenes. The value of input 1's fader parameter would be 0 when the fader is set to -72 dB. If the fader were set to +12 dB, the parameter value would be 65535. In advanced designs, parameter value changes can be specified to make fader adjustments in, say, 1 dB increments. First, we'll calculate the total number of steps between 0 and 65535. 1 dB increments would be 84 steps. Divide 65535 by 84, which equals approximately 780. Therefore, a 1 dB increment is a change in the parameter value of 780. When adding approved external control devices, the Integrator series DSPs can do the math for you with built-in resolution preference settings. We'll look at that in a minute. Rather than a fader, a button can be used to affect a parameter value. Since a button is either in an on or off state, no calculations are necessary. When the button is off, the parameter value is 0, and the fader above is passing audio. When the button is on and is red, The control value is 65535 and the fader is muted. Radio buttons and selectors are similar to faders when calculating parameter values. The value is a percentage based on the number of steps on a scale from 0 to 65535. In this example, source 1 of the 8-channel input selector is 0% with a value of 0. Source 2 is 14.286% with a value of 9362. Source 5 is 57.143% with a value of 37449. Source 8 is 100% with a value of 65535.